All right, we're ready to take notes in the Math 4 class for 2D is up next. Yes, I love Grumpy Cat. All right, today we are dealing with piecewise functions as they relate to rational equations. And also we're still going to be playing with some word problems. All right, first of all, when we have a situation, let's see, I got to turn my pen on. All right, if we have something like that, and we have what makes it a rational function is that there is a fraction involved. All right, so if we're looking at something like that, and when I happen to notice that the factors on the top and the bottom will cancel, that makes a whole, where literally it's like an open circle in the middle of the graph. Now, when the factors don't cancel, the zero is on the bottom, the vertical asymptote. So in this case, the whole would be x equals -2. Remember, if the factor is x plus 2, then the zero, the root, the solution is going to be x is -2. Meanwhile, we are scoping out the guy on the bottom there, and we have a vertical asymptote where x is equal to 1. All right? So let's see how this works with a real problem. Simplify the graph of the following, identifying any holes in the function. All right, so we can take this and say yet and yet. And so all we're left with is graphing that. We can say that there is a hole where x is equal to +3. There's nothing left on the bottom, so there is no vertical asymptote. And if I'm going to graph this, y equals x plus 2, well, that would be starting at 2 on the y-axis. Y equals 1x plus 2. 1 is going to be my slope, up 1 over 1, up 1 over 1, and so on until we get to 3. And we get where x is 3, we're going to have to do an open circle there. Now everything below that, everything above that is going to be a solid line. But I'm going to have that open circle there because wherever I have a hole, x does not exist there. All right, now I want to take you over to Desmos real quick and show you that when I have, well, you can't see the equation, you can see a piece of it over there to the side, but you know, you've got the equation of y equals x plus 2. But I want you to show you what happens when you are rolling along the line there. You should be able to see the ordered pair. But about the time we get to 3, look at what happens when we get to 3. 3 is undefined. That's because, and see, there's actually an open circle underneath my arrow. Now, if I let go, it goes away. But as soon as I hop on top of it, it will tell me, yes, 3 is undefined. There really is a hole there. So Desmos is kind of quirky that way. But anyway. All right. Let's move on to the next one. Find any holes or vertical asymptotes. Well, we know that these two guys are going to give me a hole where x is 2. And as to the vertical asymptote, I'm looking at that guy right there. And x is +3. And so that's my whole and my vertical asymptote for number 3. Let's try the next guy. We're going to have to break this up a bit. We're going to have to break this up into x plus 4, x plus 5. Of course, we're playing the game of what two numbers, when I multiply them, are going to give me negative 10, and when I add them, are going to give me positive 3. That would be plus 5 and minus 2. So now we can go back and do things like cancel. So I know that my whole is at x equals negative 5, and I know that my vertical asymptote is happening where x is positive 2. Remember, the factor and the solution change signs. Factor is x minus 2, but the solution is positive 2. And so here we've got a vertical asymptote at x equals 2 and a whole at x equals negative 5. Now we get into the issue of the horizontal asymptote. And there's a whole different thing that we look at here. We look at whether the numerator is bigger than the denominator, in this case like y cubed over y squared. The degree is bigger on top, then you're going to have nothing. It doesn't work that way. Now, when the numerator is smaller on the top than on the bottom, your asymptote is going to be y equals 0. And when they are the same, let's say that I had 3y squared over 5y to the third. Oh, no, excuse me. They got to match. 3y squared over 5y squared, then I'm going to have a horizontal asymptote at 3/5. Because what I'm doing is I'm looking at the coefficients based on the lead coefficient of top over bottom. So that's the rule on how to figure out if there's a horizontal. So, I will say that in general, you learn, to find the x-intercepts, you substitute in a 0 for y and you solve. And you substitute in a 0 for x and you solve for the y-intercept. I'm going to show you a little different way, especially with rational functions. All right. So, first of all, we've got to just find the horizontal asymptotes. Here, I have the big guy on top, and so there is going to be none. Here, they match. It really doesn't matter what the x squared is doing. I'm looking at the lead term here, and so I'm going to say y equals 2/3. Because now I am looking at that guy, the lead coefficients. All right, and here I have the bigger number on the bottom, which means y equals 0. Now this one says find all asymptotes, wholes, and intercepts for each function. So we're going to have to factor this guy first. I'm going to make a suggestion here. I'm going to suggest that you think of the guy on top like that. Negative 3x plus 6 instead of 6 minus 3x. Because at some point we're going to have to factor, and we're going to want an x plus something, x minus something. We're going to want a positive x there, not a negative 3x. So what if I factored the negative 3 out front? Negative 3x divided by negative 3 leaves me with x. Life is good. 6 divided by -3 leaves me with a -2. And so now I've factored this guy so that his factor of x minus 2 looks normal like everybody else. We're going to have x minus 3 and x minus 2 for this guy. And remember, you're still playing the game of what two numbers multiply to give me 6, but add to give me -5. And I always start with the factors of multiplication. How can I get 6? Well, that's 1 times 6 or 2 times 3. Now, how can I get this to where they multiply to a positive, but they add to a negative? They're both going to have to be negative. So -1, -6 does not give me -5, but -3 plus -2 does give me -5. So that, I've got that factored. Now, I can start asking these questions. Cancel, cancel. I've got a whole that is x equals 2. I've got a vertical asymptote where x equals 3. And when I look at, I've got x to the 1 over x to the 2. Since I have the bigger number on the bottom, there is no horizontal asymptote. Now, when it comes to my x-intercept and my y-intercept, x-intercept is all about the roots on top. For instance, x equals 2 is one of the roots from the top. And so that's going to be my x-intercept is going to be where x is 2. My y-intercept, let me change color here. My y-intercept is going to be all about the constants on the end. For instance, if I've got -3x plus 6, and I got x squared minus 5x plus 6, what I'm going to do here is I'm looking only at constants on the end. And so my y-intercept is going to be where y equals 6 over 6 or 1. The y-intercept actually makes a lot more sense because when you think about it, if I'm looking for my y-intercept, that means x is 0. And if x is 0, all that stuff at the front end of the fraction is going to cancel out. All that's left is the 6 on top and the 6 on the bottom. And that's going to happen every single time. Now, let's try that again with the next one. So the next one, we get x plus 1, x plus 1, x plus 3. Now this next one is a little bit more of a challenge. I see the 2x squared in the front, which means that I'm going to start with a 2x and an x, one way or the other. That's the only option that's going to give me 2x squared. Now, on the other end of the scope, the only way that I can factor 7 is 1 times 7, which means that my two numbers at the end are either going to be 1 or 7. Now, if I did it this way, and I started doing FOIL method, outer would give me 14x, inner would give me 1x, and I'm not going to get a 5 that way. So I'm going to try it the other way. I can play this game because I have a limited number of options here. Now, if 7 times x is 7x, 2x times 1 is 2x, and if I set a positive 7x minus a 2x, that would do the trick. Now, as to things like holes and that sort of thing, there's nothing here that cancels. So I've got nothing for holes. Vertical asymptote, I've actually got two of them. I've got x equals 1, and if I were to solve this, x equals negative 7 over 2. Where I'm literally saying 2x plus 7 equals 0, 2x equals negative 7, x equals negative 7 over 2. And let me reinforce that a little bit. All right, so I've got that. X squared over x squared, my numbers are matching here, which means I have an understood 1 in front of that x squared, and so my horizontal asymptote is going to be y equals 1/2, 1 over 2. Because the exponents match on my lead coefficients, then I'm going to use the numbers that are in the lead coefficients and use them as a fraction. Now, we said that for the x-intercept, that we would use the factors on top. And so my x-intercepts are going to be -1 and -3. My y-intercepts are going to be on the end, and that's going to be y equals 3 over -7. Or you could do that -3 over 7, either way. That's the same fraction. And that's what the second part would look like. All right, now we're getting into, well, I'll tell you what, I'm going to hit the pause button here. We're going to stop at 6, and I'll pick up the rest on the other video.